Welcome, guys. It's Modez here. Today we'll be talking about chemistry, of course, and the topic we are treating today. We are just doing calculations. So now, the first calculation we are treating today is gas law. Actually, the topic we will be treating throughout today is gas laws. So now, we know that we have different type of gas laws. Of course, we have Boyle's law, Charles law, general gas equation, ideal gas equation, Avogadro's law, Gay-Lussac's law, Dalton's law of partial pressure, Graham's law of diffusion, and so on and so forth. You get. So, but today, without wasting your time, I just want to make sure we treat 5 questions from different gas laws. So, what we'll be doing is we'll be bringing out the parameters from this question, bringing out the kind of parameters from the question, then we are going to determine what type of gas law it is. You get, so that it will be easier for us to solve. Yeah, I have my red pen here. I have my black pen here. I love using black pen a lot. Prefer it to the blue pen, the usual blue pen. So yeah, if you are new to my channel, make sure you subscribe. We talk about everything, mostly about education. It can be any type of education, either in terms of academic or in terms of graphic design and all that. But if you are here because of academics, make sure you subscribe because there will still be a lot of more videos to be uploaded on our channel. You can check our past videos. We've done videos on chemistry practicals, biology. But yeah, today we are here again to treat chemistry. So let's just go straight to the point. So now the question says 375 375 cm cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750 millimeter mercury. Find its volume if the pressure is reduced. So first of all, as I said, we'll be bringing out the parameters. So yeah, we have V1 as 375 centimeter cube. Then we have P1 as 770 millimeter mercury. Then we have V2 to be unknown, and we have P2 to be 750 millimeter mercury, okay, millimeter mercury, like that, just like that. So now from here, we already know that we are only given volume and pressure. Thereby, temperature is constant. From here, you can deduce that you are solving this question based on Boyle's law, because Boyle's law states that the volume of a given mass of gas is inversely proportional to the pressure, provided that the temperature is kept constant. So now, we all know the formula for this, and it is P1V1 equals to P2V2. So if you just make V2 directly the subject of the formula to be over P2, then over P2, then this will cancel this. Therefore, V2 will be equals to P1 V1 over P2. So now let's impute it. V2 will therefore be equals to, we have 770 multiplied by V1 375 over P2, which is 750. When you punch your calculator, V2 will be equals to, what is the calculator? Punch your calculator, 770, then times multiplied by 375, give 2, whatever, divided by 750. Yeah, so that is the answer. We have 385 centimeter cube. That is the answer for this. Now, if you can either be looking for V1 or P1 or P2, and it's not really compulsory to do it directly by making the unknown one the subject of the formula, because sometimes it might confuse you. But any method that is better for you, don't worry, I'm going to try another method in the next question instead of just changing using subject of the formula, because you need basic maths knowledge in order to be able to do that. But if you are not very good at maths, I can teach you another method in the next question. So now question 2 under gas laws also. They said at 17 degrees Celsius, now we are dealing with temperature here. A sample of hydrogen gas occupies 125 cm cube in volume, of course. What will be the volume, or what will be the volume? What will the volume be rather at 100 degrees Celsius if the pressure remains constant? So now, as I said before, you write out the parameters, and remember, always remember that when you are dealing with temperature in gas laws, always convert to Kelvin. So now we have the T1 to be 17 plus 273, which will be equals to, punching my calculator, don't want to stress my brain. So 273 plus that's 290 Kelvin. Then we have V1 to be equals to 125 centimeter cube. Always put the units also when you're writing. The carries marks. If you are doing exam, always put the units. It carries marks. So T2, we know T2, 100 plus 273. That's quite simple. You know that the answer will be 373 Kelvin, yeah? So if the pressure remains constant, okay, what will be the volume? V2 is what we are looking for again. Okay, so according to what we have here now, you can see it clearly, yeah? According to what we have here, which law do you think it is? In fact, they even give us an idea here. If the pressure remains constant, it is obviously Charles' law. The relationship between temperature and volume when pressure is constant is what Charles' law is trying to talk about. You get Charles' law states that the volume of a fixed mass of gas or given mass of gas is directly proportional to the temperature, provided that the pressure is kept constant. You get so now we know it's Charles' law, and we know that the formula for Charles' law is V1 over T1 equals to V2 over T2. So I said I won't be doing making subject of the formula. So I'll just go straight directly into fixing everything in. So we have V1 to be 125 cm cube over T1, which is 290 Kelvin, which is now equal to V2 over T2, which is 373. So here what you just do is cross multiply. So that means you'll be having 290 V2 will be equals to 125 times 273. Let's do that quickly. 125 times, you saying it, 373 will be equals to 46,625. 6,625. So in order to get V2, what you do is divide through by 290. 290. So you have V2. Now, therefore, V2 equals, then let's do it directly. Answer divided by 290. Okay, so that's 160.78 approximately. 160.78 centimeter. But if you approximately directly to the nearest whole number, we're getting V2 equals to 161 centimeter. Okay, we get, so that's approximately. Sure you get that now. So I've just tried using another formula. I hope you understand, and without wasting much of our time, let's just go straight to the next question. Okay, this question looks quite different here. A certain mass of hydrogen gas, why is it always hydrogen gas? collected over water at 6 degrees Celsius and 765 millimeter mercury at 765 millimeter mercury pressure has a volume of 35 cm cube. Calculate the volume when it is dry at STP. At STP. Okay. So now, in this question now, always make sure you write out the parameters actually. Calculate the volume. We are asked to calculate the volume, and we know that let's just write out the parameters first so I won't confuse you. So we have T1 equals to 6 plus 273, 6 plus 273, which is equals to, I want to try to make it tiny. The space is limited. So 6 plus 273. For this kind of small maths, I don't like to stress myself. Then after that, we have P1, which is equals to 765 millimeter mercury. Then we have V1, which is equals to 35 cm cube. Sure you get 35 cm cube. Then we now have T2. You know, they are saying at STP, at standard temperature and pressure. And you know that the temperature at standard temperature and pressure is 0 degrees Celsius, which is what? 0 plus 273, which is what? 270, 273 rather, Kelvin. You get. So now, we are looking for volume, right? So P2 at standard temperature and pressure is 760 millimeter mercury. 700. Actually, this question is incorrect. There's something I'm supposed to add, but we will just solve it the way it is, so as not to confuse you. You get. So V2 is equals to question mark, because that's what we're looking for. Once again, we're looking for V2. Volume is a pain. So now, this is what the general gas equation. And how do you solve this? This is going to be quite complex if you are a beginner. So the formula, the general formula for solving this is P1V1 over T1 equals to P2V2 over T2. So what I usually do is cross multiply directly. When you cross multiply, you get this P1V1 T2 equals to P2V2 T1. So we'll just input the parameters directly into it. So how do we do that? P1 is what? We have our P1 to be 765 times what? 35 times what? 273. We give us what? 760 times what? V2 times what? 279. So when we do all these times what, when we do everything together, 765 times 35 times 273. I don't want to be writing these numbers out, so but I think I'll need to, in order not to complicate things for you. 309575 will now be equals to 760 times 279. So that's 212,040 V2. So how do you get V2? V2 will just be directly equals to, now, when you divide through by this number here. So you get 7,309,575. Should I put dollars on here? Divided by 212,040. There's actually a way to do all these things faster than, but I don't want to rush things. So we have here 3.47, 34.47 centimeter cube. That's the answer. It's quite rough. So if you approximate it to the nearest whole number, of course you'll be getting 35 cm cube. So you get it like that. That's it. So now, next question. We are treating 5 questions here. So next question. So now, the fourth question. A certain amount of gas occupies 5.0 dm cube at 2 atmospheric pressure (atm) and 10 degrees Celsius. Calculate the number of moles present. Then they gave us R to be equals to 0.082 atm dm cube per Kelvin per mole. Oh, this question is quite confusing, yeah? So what do we do? Every time, remember to what? Write out your parameters. So the parameters we have volume to be equals to 5.0 dm cube. We have pressure to be equals to 2 atm. Then we have what? Temperature T to be equal to what? 10 plus 273 Kelvin, which is equals to, I want to try and squeeze it here. I want to try to squeeze it together. So yeah, that's it. 283. Then remember we have our R here, so we don't need to write it out. So now if you look at this question, hey, what is this? What do you say we should look for? Number of mole. Number of mole is represented as N. So that's what we are looking for. When you look at this question, wow, I don't know. I want to drink water, sorry. So how do you solve this question? This question now, from what you are given and R that you are seeing here, you automatically know, and it's under gas laws, you automatically know that what? This is what? The ideal gas equation. And the formula for the ideal gas equation is what? Simple. PV equals to nRT. nRT. That's it. So now, so therefore, since we have volume, here we are not converting the volume to centimeter cube is dm cube. It's not cm cube, it's dm cube. You get, sure you get decimeter cube rather. I hope you understand. So because the R here, if you are going to be converting to cm cube, that means you are going to convert this R to cm cube also. So that means you'll be multiplying this R by 1000. You get, sometimes they might give you this R as cm cube. So you are the one that will convert it to dm cube, then convert this one to dm cube, or this one might be in dm cube and this one will be in cm cube. Make sure you check the meters. You get, the meters are very important. The units are very, very important rather. I meant unit actually. So PV equals to nRT. So we have our V to be 5, then 2 PV 2 times 5 equals to N, then R is 0.082 times 27283 rather. We've converted it. So now we have 10 equals to 0.082 times 283 is what? 0.082 times 283. I think that's 23. Oh, the light. 23.21. That's N 23.21. So when you divide through by this 23.21, it gets N is equals to 10 over 23.21. That should be 2 point something, 2.331. Let me not confuse myself. I have calculator, I can just calculate it. Okay, yes. Thank God I didn't confuse myself. So 10 divided by 23.21 is 0.4308. So you have to approximate it to 3 decimal places, just like this, 0.082. So let me first write the normal this thing out. 308. So now, therefore, N is equals to 0.431 mole to 3 decimal places. It's not compulsory you write it. Just Just always make sure you convert to the lowest decimal places they give you in the question yet. So I hope you understand that. Let's just move straight to the next one. So yeah, 2 moles of an ideal gas are at a temperature of minus 13 degrees Celsius. Be careful, this minus is there. Always put that at the back of your mind. And a pressure of 2 atm. What volume in dm³ will the gas occupy at that temperature? Okay, so they are telling us that 2 moles of an ideal gas, blah 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 blah. At the end of the day, we are looking for the mole in dm³. Sorry, the volume in dm³. Rather, a mole is never in dm³. So just so you know. So as usual, we are gonna write out the parameters. So we have n to be equals to 2 moles. Then we have temperature T to be equals to minus 13 plus 273, which should be equals to 260 Kelvin. You're supposed to be shocked I'm not using a calculator right now. Then we have P to be 2 atm. Then we have R. R is a constant. You should always know it. 0.082 mole. Sorry. dm³ atm per Kelvin per mole. Per Kelvin per mole. Yeah. So that's the units. And also, what else? This is cancelled actually. It's dm³ atm per Kelvin per mole. So we are looking for V, right? Always looking for V. Why? What's wrong? What do we do to V? Why? Anyways, let's just go straight to the imputing of our formula. So yeah, the formula is PV equals to nRT. You need to note all these formulas so you don't get confused. That's why it's just better to write out the parameters so you can know the kind of formula to impute. Yeah. So P is 2 times the volume is what we're looking for. Okay, so 260 times 2, which is number of moles, times temperature. Okay, I've multiplied it by temperature times 0.82. So V, 2V will be equals to 260 times 2 times 0.082. 42.64. 42 point, what am I writing? 42. Okay, you can't even see it. 42.64. Sure you get. So therefore V will be equals to, of course, when you cross multiply by 2, you'll be getting 42.64 divided by 2. Sure you get. So let me just do it directly from the calculator here. So you have 21.32 cm³. That is our final answer. That is all for today. If you have any questions concerning everything we've done, make sure you drop it in the comments below so I can be able to answer you. And there's still going to be part 2 because we've not dealt with Graham's law of diffusion, Avogadro's law, Dalton's law, Gay-Lussac's law. We've not talked about all these ones. So there's going to be a part 2. I don't want this video to be too long for you. So make sure you share this video to your friends that need it. They really need it. You need to share it to them. And also, make sure you subscribe so that you get notified when we upload a new video. You will get notified immediately. Thank you very much. Goodbye.